Hi everyone, I'm Dr. Koenig, and this is a quick video tutorial on adding integers. Let's jump in. Here we have a problem that is -5 plus 2. And I want you to think about our negatives and our positives as anchors and floats. In real life, an anchor on a boat holds it down, right? So in this analogy, a negative would be an anchor. In real life, a float is something that holds you up. So we're going to think of our positives as floats. Now, while an anchor holds something really heavy and a float might only hold a person, we're going to think of them as equivalent in value. Every negative is equivalent in value to every positive. So a -1 and a +1 are equivalent in value. Now, to go with this analogy, let's model the problem that we have. So we have -5 plus 2. I can't draw anchors and floats, but I can draw 5 negatives. So I'm going to start with that modeling scenario. Now I have +2, so I'm going to represent that with 2 positives, only because the problem had a plus in it. That's what tells me those 2 were positives. Now, if one anchor and one float are equivalent, they would essentially land you at 0. In theory, in the analogy, if I had one anchor and one float, nothing would happen. I would not move. So when we have one anchor and one float, we call those a 0 pair. Now I want to look for every 0 pair, and I see 2 of them in this problem. Whatever's remaining tells me what my answer is going to be. I see that I have 3 negatives left, or 3 anchors in this analogy, so my answer is going to be -3. Let's take a look at another. This problem has +9 plus -4. Now I know that it's a +9 because the 9 has nothing in front of it. If it were negative, it would have to have a negative. If you see nothing there, we can assume safely that that is a +9. Again, I want to model this with positives and negatives. So I will start with 9 positives, and then I'll add to it 4 negatives. Now, the idea is to eventually move away from having to model every problem with positives and negatives. However, this is a really great way to visualize the problem as you get started adding positives and negatives. Again, I want to look for my 0 pairs. Now, when we line them up, positives on top, negatives on bottom, or vice versa, we can clearly see where the 0 pairs lie. In this case, I have 4 0 pairs, and what remains tells me my answer. I see that I have 5 positives remaining, which tells me that +9 plus -4 is 5. Now here I have a problem that looks slightly different, and that's because I have -5 plus -4. We haven't yet looked at one that has 2 negatives. Now if I'm going to model this the same way I did before, I'm going to have 5 negatives, and then I'm going to follow those 5 negatives with 4 more negatives. In this case, even though I lined them up in the exact same way, I put the 5 on top and the 4 on bottom, I don't have any 0 pairs. A 0 pair is made when I have 1 positive and 1 negative. Remember, going back to our analogy, 1 anchor and 1 float would do nothing for us. An anchor would pull us down, a float would pull us right back up. In this case, I have all negatives, so I have no 0 pairs. In order to find my answer, all I need to do is count up how many negatives I find in the problem. In this case, I have 9, so my answer is -9. You won't be able to answer every single problem by modeling the positives and the negatives. At some point, you're going to have numbers that are far too large to be drawing the negatives and the positives, looking for the 0 pairs and moving from there. So the goal is, of course, to figure out a more efficient way to solve the problem. That's a large part of middle school math, is learning not just how to get to the answer, but how to do so efficiently. So let's take a look at this problem. This one has -15 plus 23. Now, when I'm looking at a problem like this, ultimately I want to think, am I moving from negatives to positives, positives to negatives? Do I have 2 negatives, in which case my answer will stay negative? And otherwise, generally, what's going on with the numbers that I'm given? In this case, I see that I've got -15 plus 23. And when I look at this problem, I know that I'm adding a lot. So imagine a number line. I've got 0 in the middle, and -15 would be somewhere on the left of 0. Now, if I'm adding a positive number, just like in addition, before there were integers, before there were negatives, I'm moving to the right-hand side. The 23 tells me that I'm moving 23 spaces. Now, what I know by looking at my number line is that 15 spaces will get me to 0. So what I really want to know is how much more than 15 am I going? What's interesting about this problem is that while it looks like addition, we actually solve it using subtraction. I need to know how much more than 15 is 23. I solve that by subtracting 23 and 15, and I'll see that 23 is 8 larger than 15, which means I have to move 8 spaces past 0 when I add 23, and my answer is 8. I hope this video gives you a start to adding positives and negatives. Here are some things to remember when you're solving problems like these. If you're adding more floats than you are anchors, more positives than negatives, you're going to end up with a positive answer. If you're adding more anchors than floats or more negatives than positives, you'll end up with a negative answer. Now, as we noticed, when you're adding a positive and a negative, it's a lot like subtraction. That's an important piece to this. And then if you're adding only anchors to negatives, you'll actually get an answer that some people think of as a bigger negative. You're getting a number that is further away from 0 and further down the number line on the side with the negatives. Again, I really hope this gave you an understanding of the basics when it comes to adding positives and negatives and positives, or two negatives. Thanks for coming, thanks for watching my video, and I'll see you next time.